Hello, pre-calc students, and welcome to the video on graphs of logarithmic functions. Today we're going to talk about identifying domain of logarithmic functions and just graphing them in general. Let's go ahead and get started. All right, let's start by looking at the graph of the exponential function f of x equals 10 to the x. The domain, remember, of all exponential functions is minus infinity to infinity. The range is 0 to infinity. And the horizontal asymptote is y equal to 0. And let's go ahead and just check that in Desmos. So let's go to Desmos and graph 10 to the x. And here we are in Desmos. Let's open the graphing calculator and graph f of x equals 10 to the x. And there is my nice graph of my exponential function. And now let's graph the inverse function that is log of x. So the domain of log, remember we have to start at 0 and go to infinity. Can't take the log of a negative number. The range is minus infinity to infinity. And what about a horizontal asymptote? Does that make sense in this problem? Let's go ahead and graph log of x on Desmos and see what it comes up with. Let's call this g of x. And there's my log graph. So let's go ahead and look at that. So it doesn't appear to have a horizontal asymptote. If we zoom way out, we can see that it is increasing slowly but surely as it goes along. And we can see that it does have a vertical asymptote. So what was the horizontal asymptote in my exponential function has now become a vertical asymptote in my inverse function. So it has a vertical asymptote at x equal to 0. So we're like, horizontal asymptote? Nope. Vertical asymptote. Let's cross that out and write vertical asymptote. And remember, vertical asymptotes are the form x equal to a value because you're not left or right. You're stuck at a particular horizontal value, x equal to 0. All right. So this is another graph of a log function, and we can just look at the graph and just notice that we recognize the domain and range. So we can see the domain. If we were looking at this graph, we would see that the very smallest value is 0 and not included. So again, of course, it's 0 to infinity. The range is minus infinity to infinity. And the asymptote is a vertical asymptote at x equal to 0. And when we draw those in on a graph, lots of times we just use a dashed line. So let me just go ahead and draw that in. We use a dashed line for the asymptotes. We can just kind of draw that in. All right, so now that we've talked about the domain of a log, let's see if we can do it for some logs that are a little bit more complicated. So the first example we're going to look at is the log of x plus 3. So remember, we can't take the log of a negative number. But what's inside the argument to the log isn't just x, it's x plus 3. So for example, if x was negative 2, normally we couldn't take the log of that. But if we add negative 2 to 3, we get to positive 1, and we can take the log of 1. So when you're looking at the domain of a log, you need to make sure that you just check what is inside the log and make sure that that is greater than 0. So the domain is going to be where x plus 3 is greater than 0. And if we solve that inequality, that would be is when x is greater than negative 3. So my domain would be negative 3 to infinity. That is not a 3. It was negative 3 to infinity. All right, and it says, what is the asymptote for this function? Well, the asymptote is always going to happen when whatever is inside the log is equal to 0 because that is undefined. So my asymptote would happen at when x is negative 3, x plus 3 is 0. So my vertical asymptote is going to be at x equal to negative 3. And that helps because that's also the equation of the line of the vertical asymptote. Or let's try another example of this. Let's look at, oh no, this one's missing its log function. Hang on. When I imported these guys, seriously. All right, let's try another example. When I imported these into my Google Docs and PDF, sometimes I lose the log, so we'll just rewrite it. Log of t minus 2 plus 1. So now we need to also just look inside the logarithm. We don't really care that much about the plus 1 outside. We need to make sure we don't take the log of a negative number. So we need t minus 2 to be greater than 0 for our domain. And that will happen when t is greater than 2. So the domain is from 2 up to infinity. And our vertical asymptote is going to be when x equals 2. All right, let's keep going. Why don't you guys try this last one? Go ahead and try and find the domain and the vertical asymptote for h of z. All right, to find the domain, did you solve where 12 minus 3z is greater than 0? So let's go ahead and solve that. Minus 3z is greater than negative 12. Divide by negative 3. Remember, when you divide by a negative and you're solving inequalities, you switch the sign. So z needs to be less than 4. Z needs to be less than 4. So my domain is minus infinity up to 4. All right? And my vertical asymptote is going to happen at 4. That would be what's inside the natural log is equal to 0. All right, so that's finding the domain of logs from an equation. Oh no, what have I done? Okay, here we go. All right, so that's the domain of finding logs from an equation. Let's practice graphing some logs, and we're going to graph it by hand. Now, Desmos can graph logs of different bases, but we're going to practice doing this one by hand to just build some practice. So the way we graph by hand is we just make a table of values and we plot points. So we're going to pick some x's and we're going to compute some f of x equal to log base 5 of x. Now when I'm trying to find values that are going to work out nicely here, I want to take values that will have I want to put inputs in that are going to be powers of 5. So, well, we know we can't write 0 because you can't take log of 0, so that's not even in the domain. Let's try 1, let's try 5, let's try 25, and 125. Well, let's not do 125. And so if I put in 1, I would have log base 5 of 1. And what do I raise 5 to get to 1? And that answer is 0. So that's the point 1, 0. If I put in 5, I have log base 5 of 5. 5 to the 1 is 5, so that's the point 5, 1. And finally, log base 5 of 25, which is 2. So I have over 25 and up 2. So that gives me quite a few pretty good values. Let's go ahead and plot those points on my graph. So I have 1, 0, 5, 1, and 25, 2. So from 1 out, I have a pretty good guess of what this graph is doing. Between 0 and 1, I don't have any data points. So what I'm going to do is I'm going to pick a value between 0 and 1. And I'm also going to pick a value that's a power of 5. So I'm going to put in a fifth. And log base 5 of 1/5 equals negative 1. So that tells me the point over 1/5 up negative 1. So let's plot that one. That's going to be like here. And then we can kind of remember how it has that asymptotic behavior. So if we're going to sketch in this graph, let me move it up just a teeny bit. If we're going to sketch in this graph, we're going to be getting close to that vertical asymptote. Then we curve, and we have a nice slow increasing function here. See if I can make it be slow enough. There you go. And then this is going to keep going. So there's my graph by hand on my logarithmic function. Let's go look at Desmos so I can show you how to graph those in Desmos. So let's get rid of these guys. If you wanted to graph f of x equals, I don't know what I named it in the thing, but let's graph log base 5 of x. You go log, and then you just go underscore to get down in the subscript. And I put b, but I want 5 of x. And it can do any base for you. You can see that's the graph we just did. We just did by hand. If we look along at our values, we'll see there's 5, 1. And if we went out farther, we would get to 25, 2. Etc. So you can graph different bases in Desmos. All right, let's talk about graph transformations. So if we think about, oh my gosh, I've lost a lot of logs in this. I need to fix this. This should be log of t plus 2. Sorry. When I translate these, sometimes things get lost in the equations. F of t equals log of t plus 2. So when we're thinking about this, how has this function f of t been transformed from a basic log equation? It's the same way that all transformations happened. We can see we've added 2 to the input, So that means it is a shift of 2 units left. Right? If it was added on the end, that would be up and down. But since it's added to the input of the log, it's going to be left and right. So what is our domain of our new function f of t? Well, we need t plus 2 to be greater than 0. So we need t to be greater than -2. So our domain is -2 to infinity. And our vertical asymptote is at t equal to -2. And now given our graph below of f of t equals log t, just basic log, how could we draw the graph of f of t? Well, what we know is it's just been this graph shifted 2 units to the left. So instead of having my vertical asymptote at 0, I'm going to have my vertical asymptote at -2. So there we have that. And all my points have just been shifted 2 units left. So what was here at 1, 0 is now going to be at -1, 0. 2 units left. 1, 2. And let's look at another really good point. Let's see what's happening at 2. We're about up here. So we would be about here when we hit 0. So got that point there. And then maybe a little at 3, we're going to be back at 1. So you can kind of see what's happening. And then let's graph this one. 1, 2 here. And we can just shift the whole graph 2 units to the left. Oh man, I lost my graph there. There we go. All right, so just shifted graph 2 units to the left. Same way that all graph transformations work. Let's try another one of these guys. Let's think about the graph of natural log of x minus 1 plus 3. What transformations have happened in this graph? Well, we did something to the input and we did something to the output. So to the input, we have a subtract 1, so that's 1 unit right. And then we add 3 to the end, so that's 3 units up. And what is a domain of g of x? Well, we need x minus 1 to be greater than 0. So that means x needs to be bigger than 1. So my domain is 1 to infinity. And that makes x equal to 1, my vertical asymptote. So given below, here is our graph of natural log of x. We're going to shift it 1 unit right and 3 units up. I did something crazy. Hang on. Too much. So we're going to shift this graph 1 unit right and 3 units up. So let's just go ahead and start at an easy point. Let's start at this 1, 0. 1 unit right, 1, 2, 3 units up. And let's pick another point. How about just here at 5, and it's about this grid. So we're going to go 1 unit right and 3 units up. So 1 unit right and 1, 2, 3 units up. So that will be that point. Let's pick another one farther down. You're getting the idea. Let's do like this one here. So we're going to go 1 unit right. So we're going to be right about here. And we're going to go 3 units up. 1, 2, All right, so now we're going to just kind of connect the dots, being cognizant of my vertical asymptote here. And I'm just going to do this, and then this, and then, oh, I missed. Let's try that again. I can do better than that, at least on that last little section. Well, you get the idea. 1 unit right, 3 units up. All right, and that is going to be the last example we do in this video. Thank you.